flight. It's pretty neat. So basically, type another RxJava type, or you can even go to some other custom class that you've written. So what if we make this return the around clause that we had written before? Now we can take backspace in our setup here by enabling the function in here and moving the rest of this up to there. So what do we get to do here? Well, if we made that scope width just return an implementation of that function that we had showed earlier, we get something like this. Now, this mostly works, except the types are erased again. Because once again, we need that generic showing up here, and the IDE is still not auto-completing this for us. So this isn't going to work. We need to basically get back to work on this again and try to find another way to get this going. So we need to get types into the toSignature to pass around, and it can't infer this from outside of the subscribe method. So how can we go about this? Well, it turns out if you new up a new instance, autocomplete works again. So we created this scoper class, which basically just implemented the converter function, takes the scope as a parameter, and then you implement the apply method and whatnot in here, and then you return an instance of the around clause. I know that this terminology is getting a bit thick here, but stick with me. We call subscribe under the hood, and what this means is because we can actually read Rx APIs, we can actually just delegate everything to RxJava's implementation of the observer under the hood, and we can even read other useful information that RxJava gets back to us, such as Lambda consumer interfaces that RxJava has for some types. So we have a new problem here. Those generics that we put on the methods are now useless, and we need to propagate them. So now we can make the around clause itself generic, and our code looks like this. So if you do this with a new anonymous implementation, or just a newing up a new instance, the IDE auto-completes it again. It doesn't work with the static factory, but it does work if you just call new. This is again weird, but we're trying to cater to what was going to be the most ergonomic for developers. So can we do more? Yes, we can. So we've lost the notion of subscribe here. This looks a bit weird because if you're used to RxJava and you're used to going, this, that, and then subscribe at the end, it's not obvious that that's happening in here at all. So we do it under the hood, but it's a bit weird. So revisiting our around clause, its implementation is now actually just a proxy to subscribe. So we just make that explicit. Just call it a subscribe proxy. And really, we just change the method names to subscribe, drop in the empty subscribe, etc. Drop it into here. It looks like a real subscribe. Under the hood, it's actually a different subscribe than what's in RxJava. But remember, the metaphor here is that API design is an art. And in art, if it looks right, it is right. That joke would have landed better if my clicker was in the queue. There we go.
True.
Yeah. So this constituted what I'd call basically a V5. So it stayed like this for a long time inside of Uber, but we were still itching to make that converter function more factory. Like newing up a scoper works, but it's not totally obvious what a scoper is when you look at it. It seems a bit weird that you're kind of like newing up this random thing to put in here. There's a few other reasons that we want to do this, namely for we want to be able to change implementation details under the hood easily. So remember what I mentioned before about just returning interfaces from static factories. With this, people actually were able to tie things to implementation details of specific scopers. And if we wanted to change that, we never really could because we had to stuff everything into these scoper classes. We also wanted better readability, and like I mentioned earlier, no one knows what a scoper is. So fast forward to basically like October of last year, I started doing a bunch of research to see what cases would work with autocomplete in the IDE and what wouldn't. And it turned out that if you had a method on the end with no parameters, it autocompleted. It didn't autocomplete if you took any parameters. So we changed the API to look something like this. It's a little bit of a horizontal change. It didn't really actually feel that much better or worse, but you did get a nice sort of autocomplete story in here, and we had at least a little more flexibility with the types that we returned from the static with factories. And then we sort of live with that. Again, like I said, not pretty, but one thing that I've learned working at Uber is that a lot of engineers are willing to deal with an astounding amount of bullshit in their code. Yeah, so we kept going with this. It was a bit nicer in Java 8 once we got like D8 in our build system. This keeps clicking twice sometimes for me. It's throwing me off. There we go. So you could have a case like this. It's still a bit ceremonious. The indirection might be nice in the future, but right now, what we really wished that we could do was something like this, where we just have one static factory entry point, and that was it. But again, like I said, we couldn't do this because IDE autocomplete never worked. And then I went to TriCon New York in September last year, and I was talking with someone there about being stuck on this piece and how the IDE just wouldn't autocomplete in weird scenarios. And she says, "Have you reported an issue?" She's a genius. So this was October 1st. Filed this issue saying autocomplete doesn't handle when the method has parameters. And then it was fixed October 4th. Because IntelliJ is just awesome. And then it was released in IntelliJ 2017.3 about a month after that. So that was great. That was about when I gave this talk before, so now we're in uncharted territory on this. There's been a few major changes that we've been able to make since then. The big one was that for observable overload that we wanted. Around the same time that we were going to be able to do that, remember I mentioned at the beginning that I always thought it was a bit of a design flaw in RxJava that we used the same function type for each overload, and that meant that you couldn't create a composite interface that implemented all of the different types. So I went back to the RxJava issue tracker, and it turned out that they agreed. And so we actually added a new operator called as that took in custom interfaces for each one of these converter types, and that meant that we could actually just make an API that looks like this, and under the hood it returns you this monstrous auto-dispose converter that extends every single one of the different types of converters that we support. But that meant that we only had this one auto-disposable factory method for everything, which simplified things a bunch. So you just drop this in, you say your normal stream, then .as auto-disposable with the scope, and then subscribe, and that's it. We got the one-line niceness that we were looking for, and we were really, really happy with that. Another big change that we made was around the decision to use a maybe to represent scope. So before we thought, a scope might emit or it might not, and we thought, well, that sounds like a single. And then we thought, well, what if they never emit, then they just emit like a completion. You want to say you're unbound. So we said, okay, so it's a maybe. It turned out that that was totally useless. Whenever it emits a completion event, it's not like it lets go of any references and can GC things and clear things up. It just sits there. It nulls out like one field somewhere for internal use, and that's it. So it's just as valuable as if they have a single that never emits. So now we have a single. We also don't care about the type. Like we just ignore the element that it emits, which in RxJava, that is literally the definition of a completable. If you call ignore element on single, it gives you back a completable. So that's what we did yesterday. And yeah,
nice.
this is super simple semantics wise. You just give it a scope. When the scope calls complete, then it's done. And that's much easier cognitive overhead for developers using it. And you can even take this a step further and say that we don't care about any operators or anything incomplete. We can just take this completable source interface. So anyone can give us any implementation of a completable if they want, not necessarily RxJava's. This keeps auto-dispose's API surface area much smaller as well. It keeps us from trying to make assumptions about the types of objects that users are giving us. And that kind of wraps up to where we are today. So back to our meta question, what makes a good API? And the answer is, it's still hard to say. But for the sake of giving some pointers in this talk, and at the risk of some subjectivity, here goes. So first one is prefer exposing interfaces. Now, what I mean by this, in cases where you have, say, like static factories, exposing an interface means that you can change implementation details all you want under the hood, and you're not going to risk breaking your public API. This is extremely valuable, especially if you're going through a lot of early iterations, so that you're not just breaking consumers every time. You can hide tons of implementation details under this in a safe way. You can also return completely different implementation details. It also lends itself well to plugin systems if you want users to be able to stub their own implementation. With the scoper API that we had before, we had lost this, and everything had to go into that scoper. So by being able to go back to a static factory approach, that really gave us back this flexibility that we wanted. Another part of this is preferring composition and accepting external implementations. Inheritance can be inconvenient. Now, I know this sounds like a fancy way to say composition over inheritance, but stick with me. So when we look back at one of our earlier problems, and we were trying to accept different implementations from outside, there's going to be cases where you can't just assume that users are going to want to make their stuff implement your requirements. This gets back to having a library that fits well within an ecosystem, not necessarily expecting the ecosystem to fit well with you. Yeah, it's more flexible to the user's needs. Yeah, the published subject example is a great example of where it can be just inconvenient. And it also, as a library maintainer, keeps your logic agnostic to implementation details as well. When you're writing a library, it's very easy to fall into the notion of like, I know how this works under the hood. I can write a test that assumes this or knows that this is the behavior. If you accept interfaces, you have to trust that they're abiding by the public API of that interface in the same way that you expect them to trust yours. Completable source, which was the recent change we made yesterday, is another good example of this, where we actually can't go through and make assumptions about what operators we can call on the input source. We can only call subscribe on it. Prefer final by default. This I know is somewhere in the effective Java Bible. Now, part of this is the usual composition over inheritance bit, but part of this is also about limiting API surface area and letting the compiler enforce the semantics for you. There's a good part in this also regarding testing, which is not saying that final necessarily helps testing, but rather I say final and there's some group or contingent in the company that comes and says, it makes for bad testing. And to that, I would say, maybe if you're tying yourself to something like Mockito and Mockito doesn't support final mocking or something. But this is actually really powerful for an API design standpoint, because if you're saying it's final, you're saying, I don't support inheritance on this. And if someone is trying to force that in a test anyway, they're saying, I'm going to break your API for my test cases, and then basically you end up with brittle tests. Another sort of good quote that I like about this from the testing standpoint is that if you can't verify, like if you feel like you have to use Mockito to verify implementation details under the hood, that's something that your users are not afforded if they don't use Mockito. Especially, you don't want to expect them to use Mockito, I guess, in production to verify things. So if you can't verify behavior from your public API, neither can your consumers. Another one is identify foot guns early. So who here knows what a foot gun is? So a foot gun is a gun that is designed solely for shooting your foot.
Not a gun that comes out of your foot?
No. Yeah, so that's recognizing just odd cases in your API where like this is clearly going to lead to wrong behavior. If the user tries to do this, then they're going to do something unexpected, or it's going to lead to behavior that they don't want, and in some worst case scenario, it starts crashing their app. Avoid dependencies on lint. Now, there's two ways of looking at this. So, a static analysis artifact for error prone with autodispose, but that's so that you can enforce that it is used at all. It's really useful for cases like, hey, I'm subscribing to something in my activity, and you want to just have a case where if someone forgets to use autodispose, it warns them on that. But there's another class of lints which basically says, hey, this is the correct way to use this API, or the correct way to use this library. And that's basically the entire existence for IntelliJ inspections and error-prone and different static analysis libraries like this, because Java is full of cases that are inviting you to do the wrong thing. So if you find that you have cases in your API where you're looking at it saying like, yeah, this could be used the wrong way most of the time. I should write a lint that makes sure people use it the right way. The problem is actually probably a step back in saying like, can I eliminate this area of confusion entirely in my library? This is a good metaphor for that. Yeah, it's a powerful tool, or lint is a powerful tool, but you should use it defensively, not as an expectation that people are going to need it to put them in the right place. IDE experience matters. So this is something that gets missed a lot in library development or just regular day-to-day development. It's worse if you work in web. It's things like readability, things like gotchas around there. Like, it's really important not to put that burden on your users, because that's something that stacks up not only from a first impression standpoint, but it's also something that if they have to use the library, and they're getting bit by that several times per day, that's time wasted on their part, and it's going to make them want to look for something else. It's going to make them have negative feelings towards your library. If they're coworkers, it might make them have negative feelings towards you. IDE experience is really, really important, and the best way to basically enforce that is to basically make sure that you're using this product yourself, whether it's necessarily in your day-to-day, or if you're writing your tests against your own public API and finding out that whenever you're exercising your API, there's weird potholes that keep slowing you down. Those are actually really important. And the last one is basically crack eggs and make omelets, which is to say, if you have a new library, start with a minor version. You don't have to start with 1.0 immediately and then commit yourself to that for the end of time. With Autodispose, we started with the 0.1 release, and we're currently on 0.8, 2 years later. And you should basically be willing to make breaking changes as long as you need to before you're comfortable enough to commit to a stable API. It's really, going back to the art metaphor, it's a lot about sort of sculpting this API and seeing how it grows and develops over time. And as you start using more areas of it, finding rough spots that need to be smoothed out, or going different directions with it entirely. You're wanting to, with the library, you're trying to account for flexibility that can really only be designed for over time as you see how people experience and use your library. So coming full circle, at the end of it all, you might actually make a release for the library too, and then find that you completely missed something. And you can react to that by either building a wall, like I showed earlier, or you can even adapt to it with a nice path that recognizes, hey, we noticed that this is what people are trying to do. Maybe in a V2 we'll do something different, but we're going to also optimize for the developer experience here. Change happens. You have to be open to it. Keep the developer experience in mind. Put yourself in their shoes. You might not get it perfect, but you can try your best. And on that note, so Autodispose has gone through a bunch of change recently, and I think
snaps.
We'll go with RC1 for now. But I did spend a bunch of time trying to time this nicely for this, and if I can actually. I've never run all three of these commands at once, so this might not work. But yeah, any questions? Or that's it, by the way. Yeah.
Right. So I guess I'm curious, especially after with regard to your code base, how do you guys went about your deprecation system or anything like that, about introducing new breaking APIs and stuff like that? I guess I'm wondering if you guys learned anything about how to roll those out and deprecate them properly.
Within the context of Autodispose, or just in general?
Autodispose, or I guess in general too, but specifically with Autodispose.
Yeah, so it depends on. So the question was, how do we go about deprecating major changes in libraries or internally? It depends on the on where the code lives. So internally, we have a giant monorepo, but obviously Autodispose lives on GitHub. So Autodispose changes, whenever we make a breaking change, they happen asynchronously. And whenever we update to that version, we have to do one atomic mass migration in the code base. For breaking changes internally, where we're within the monorepo, we basically have to do it as part of the change, which is a little bit frustrating and not my favorite approach as a library developer because it sort of requires me to know how other consumers like APIs and build setups and features work. If it's a focused enough library, then you kind of end up designing it in a way where like, this is how it worked before, this is how to use this now, and you can kind of like cargo code that into place. If it's something that's more of like a framework, then I don't really see how that easily works in a large monorepo code base. We use deprecated sometimes, not necessarily in the case of like, we want to give people time to migrate, but it's more that we want to get the new thing in and then get to the migration of it later. A lot of times what we'll do actually is we'll deprecate something and we might leave some sort of shell of it up that just delegates out to the new implementation that we want, but we'll leave the old one there just for, not to go and like mass migrate everyone. One thing that we did recently, which worth the wait, because it has to do with Stacy.
Okay. Oh God, yeah.
Yeah. So this is great. We have like 3 or 4 of these in the code base at this point, which is actually, it's kind of fun because people actually now are interested to go see what the deprecation warning looks like, which is not something the luxury we usually get. And then how do I?
So did I can clearly see where the inspiration came from.
Yeah. How do I? Stacy, where's your tweet?
Oh, it's somewhere on there.
I'm
Sure. Or maybe it was just on the Slack channel.
Oh, maybe.
I felt like it was on Twitter.
Yeah. Anyways, Stacy sends us this picture of another tombstone of a key value store. Oh no, it wasn't this. It was the iOS one.
It was the iOS one, right?
Yeah, that's right. Enjoy my roommate's dog over here.
Yes,
There
you
it
got
is.
it. No, up a little bit.
Yeah. So
Go
this,
down.
Yeah. So this was another thing we deprecated, which was the iOS dependency graph, and our manager actually had a cake made. He actually, whenever he went to the cake place, he was like, "Sorry, this is a bit weird." And they're like, "No, we've made a tombstone cake before. It's fine." And Stacy responds with this. I think it's from Oregon Trail.
Yes, it was.
Yeah. So, anyways, that's how we manage deprecations at Uber. We make tombstone jokes and post it on Twitter. Yeah. Basically, it depends on your setup. I really like when libraries are in individual, like separate repos where they can be updated asynchronously. That is both a benefit to the maintainer of the library because they don't have to go and like commit to making this giant atomic breaking change in the whole code base, and it also is useful for users because they can update, whenever it works for them, which can be really great for me with this new auto-dispose release because there's a bunch of breaking changes there, and those like older versions of the APIs that I showed earlier. Those were deprecated until I deleted them like 2 days ago. And that's everywhere in the Uber code base. So I'm going to have to update all of those at once at some point. Structural replace in IntelliJ is really great for this. iOS users, I'm sorry, tooling is not there. Any other questions? Cool. Thanks for having me.
Awesome. Thank you. And we have a small little gift for you because we didn't know what your capacity was on your thing, but
Going straight to the
every day you get every time you have a question, pull a fortune from the fortune dispenser.
Awesome. Thank you.
Enjoy. still uploading? Or still pushing everything for auto
It
dispose?
is uploaded now, so
All right, I'm hitting refresh.
I have to publish it in Sonatype, which has a UI that was built in 1994.
Well, we've got it on video, so. If somebody was wondering, did it really happen? Yes, it did. I'm still hitting refresh on the GitHub repo.
Oh, I haven't pushed it yet. This is just the upload to.
It's just doing the.
Yeah, give me 1 second.
So, I was gonna say.
What time's your flight?
Let people fly like
At 10:30.
Oh, okay.
All the other ones.
Stuff here is really easy as far as the getting in and out. I'm going to stop the stream.
And they usually bring one down to this.
All right, now it should be on GitHub. Oh no, I messed it up. Shoot.